Very well. So let us continue our lecture. We're going to talk about Locators Rule. Let me go through this one and the other one. So Locators Rule officially say that I keep forgetting about S. So Locators Rule says that suppose you have two functions and you have two differentiable functions. It means that the limit of the direct definition that we define for the derivatives, both of limits exist. Let f of x and g of x be two differentiable functions, and suppose the derivative of g is never 0. Very well. Consider the derivatives on an open interval. Remember that we are really concerned about the boundaries from left, from right. So when we're talking about differentiability, we try to avoid the boundaries over an open interval like A, comma B. And suppose the limit of function f as x approaches a number like a is equal to 0, and also the limit of g of x as x approaches a is also 0. Well, I'm going to write down the second case down here. Then the limit of f of x divided by g of x as x approaches a is similar to the limit of the derivative of f over the derivative of g as x approaches a. So note that if at this point you take the limit of the derivatives and it is still, note, if it's still equal to 0 over 0, then we have to continue taking the derivatives from the top, from the bottom. This is equal to the limit of second derivative of f, the second derivative of g as x approaches a. And again, if this is equal to 0 over 0, you can continue taking the derivatives from top, from the bottom, and find the limit eventually. Well, we have another case if it's 0 over 0, or if it's infinity over infinity. Note that we can apply the Locators rule when the limit of f of x over g of x as x approaches a is equal to positive negative infinity over positive negative infinity as well. It means that the limit of f of x over g of x as x approaches a is equivalent to the limit of f prime of x over g prime of x as x approaches a. And again, note that if still you get infinity over infinity, note, if we still have infinity over infinity plus minus, then we can continue this process. We can take the second derivative of f and second derivative of g. And you can continue this process until you end up with something that is not in the indeterminate form, 0 over 0, infinity over infinity. So we're going to write this down with 3 dots. So a couple of examples for us, see how we can apply Locators rule. We saw some examples before, and let us take a look at more examples. So our very first example says, hey guys, take the limit of this rational function. What is the limit? I'm not asking to find the derivative. I'm asking to find the limit. Find the limit of ln of x divided by x minus 1 as x goes to 1. Guys, be careful. If you're confusing this with taking the derivative, you might end up applying quotient rule. I'm not asking to take the derivative. Let me write that note here for you. Note. This question is not asking to take the derivative. So we cannot apply the quotient rule. That's an important note for you. Well, question says, hey, take the limit. Remember that very first step in taking the limit, step 1, was substitution. Sometimes we're lucky with substitution, we get a number. So let's plug in 1. We get ln of 1 divided by 1 minus 1. Ln of 1 is 0. 0 divided by 0. It is in the form of indeterminate form. So in step 2, we try to get rid of the factor that makes 0 over 0. But here, well, we cannot apply factoring. Here, we do not have the technique of using the conjugate. We cannot do that. What we can do, we can use what we learned so far, Locators rule. Locators rule says, well, just take the derivative of numerator, take the derivative of denominator, then start finding the limit. So this is equivalent to the limit of the derivative of ln of x divided by the derivative of x minus 1. After that, we start sending x to 1. So remember that when you're taking the ln of u of x, if you have u of x, the composition of two functions, the derivative is equal to u prime divided by u. So now here you have ln of x. The derivative of x is just 1 divided by x itself. So on the numerator, I have 1 over x. On the denominator, the derivative of x minus 1 is just a linear expression, is 1. And my x goes to 1. So now at this point, I substitute. I already applied Locators rule. Now the step is substitution. I get 1 divided by 1 over 1, which is equal to 1. Nice and easy. The y value, remember that the limit is the y value. The y value as x approaches 1 is 1. on the vertical axis. This is our y value. I'll give us another example. Let's make it a little bit more interesting. Suppose the question says, well, find this limit. Limit of x times ln of x as x approaches to 0 from right-hand side. Okay. X approaches to 0 from right-hand side. Well, remember the graph of ln? Let us try to analyze what's going on here. This is our x-axis, this is our y-axis, and this is the graph of ln function. Graph of ln behaves like this. So, as we go toward 1 from, okay, let's just write down. As we go toward 0 from right-hand side, where does my y value go? My y value starts going downward. So this guy, as x approaches to 0 from right-hand side, goes to negative infinity. Well, this guy is just line y equals to x. So this is ln of x. And then the next graph is the graph of y equals to x. As I'm going towards 0 from right-hand side, well, my y value goes to 0. So what I have 0 times negative infinity. 0 times negative infinity. But what is the value of 0 times negative infinity? 0 times negative infinity. This is another case of indeterminate form. What should we do when we have a case like 0 times infinity, 0 times negative infinity, 0 times positive infinity, and so on? So note that when we have 0 times infinity in general, or 0 times negative infinity, we need to make some adjustments. What adjustments? The adjustments that help us to rewrite the function. So when we are taking the limit, it is going to be 0 over 0 or infinity over infinity. So that the limit becomes infinity over infinity or 0 over 0. How so? I'm looking at this function. This is x times ln of x. Well, go back to intermediate algebra. Go back to elementary algebra. This is x. If I write this as ln of x divided by 1 over x, they are equivalent to each other. Here, if you multiply x by ln of x on the denominator, you end up with 1. So you get x times ln of x. So it means that since these two functions are equivalent to each other, their limits must be the same. Well, okay, let us start taking the limit. Limit of this function as x goes to 0 from right-hand side is equal to the limit of this function as x goes to 0 from right-hand side. Now, what is the difference between them? The difference is when I take this limit, it gives me 0 times negative infinity. If I take this limit after substitution, remember that the very first step, is substitution. ln of 0 from right hand side. 0 from right hand side divided by 1 over 0 from right hand side. Now I'm dealing with this function on the denominator. 1 over 0, 1 over x is the reciprocal function. The reciprocal function. This is 1 over x. It has two parts. As I go to 0 from right hand side, well, my y value goes to positive infinity. So I have 1 divided by 0 from right hand side. For ln, I have negative infinity. For 1 over 0 to the positive, or your reciprocal function, you get positive infinity. Well, we just learned about Locators Rule. It says as long as you have 0 over 0 or infinity over infinity, negative, positive, it doesn't matter. You can start taking the derivative of the numerator, taking the derivative of the denominator, and take the limit one more time. So we're not dealing with this function. We written this as f of x divided by g of x. This is your f of x, and this is your g of x. So let's apply L'Hopital's rule. You have the limit of f prime. So we are taking the derivative of ln. We divide that by the derivative of the reciprocal function as x approaches to 0 from right hand side. Well, the derivative of ln is 1 over x. The derivative of 1 over x is negative 1 over x squared. And we are finding this limit as x goes to 0 from right hand side. But let us simplify this first. Simplify. When you simplify this side, what do you get? You get x squared divided by negative x, or just minus x. This is equal to the limit of minus x as x goes to 0 from right hand side. Well, you have a line. This is just a very nice function, linear function. To find the limit, you just use substitution. By substitution, you get 0. So the limit of this function as x approaches to 0 from right hand side, or the y value of the function, is just 0. Y value vertical. Very well. So what if we have something like this? The question says, find the limit of 1 over ln of x minus 1 over x minus 1 as x approaches to 1 from right hand side. Okay, very good. Remember that here you have a limit. The very first step is substitution. If we do the substitution, you get 1 over ln of 1 from right minus 1 over 1 minus 1, 1 over ln of 1, which is 0, minus 1 over 0, which is infinity minus infinity. Guys, infinity minus infinity is not 0. So this is, it is not 0. It's indeterminate form. So what should we do? Take the common denominator. We are going back to algebra. Nothing calculus about it. just taking the common denominator. Why is that? Because it's not 0, it's indeterminate form. So it means that you're finding the limit of x minus 1 minus ln of x divided by ln of x times x minus 1 as x goes to 1 from right-hand side. So we did some algebra. We created something new. Now we have to do the substitution. So let us substitute. If you start substituting 1, what you get 1 minus 1 minus 0 divided by 0 times 0. So you get 0 over 0, which is indeterminate form, and we can apply Locators rule. Now calculus. You have to take the derivative of f, take the derivative of g, and then take the limit one more time. So this is f, and this is g, and we are taking the derivative. The derivative of the numerator, the derivative of the denominator, we're using the Locators rule. So here it is equal to the limit of the derivative of x is 1. The derivative of 1 is 0. The derivative of ln is 1 over x. Here you have the product of two functions. You have to apply product rule. The derivative of ln is 1 over x times x minus 1 plus the derivative of x minus 1, which is 1 times ln of x. X goes to 1 from right-hand side. We're done with calculus part. Now do the substitution. Substitute 1. What do you get? You get 1 minus 1 over 1 divided by, here you have 1 over x, which is 1 over 1 times 1 minus 1 plus ln of 1. What do you get? You get 0 divided by, very well, 0 plus 0, which is 0. We have 0 over 0 again. What's the meaning of that? We have to reapply Locators rule one more time. Now, calculus. Very well. So, what is our function f? Our function f, or f prime in this case, is this function. Our function g is this function. We can make some simplification as well. 1 divided by x times x is 1, and you have negative 1 over x. So this is equal to the limit. I'm just going to write this in simpler form. 1 minus 1 over x divided by, I distribute 1 over x into parentheses. I get 1 minus 1 over x plus ln of x, as x goes to 1 to the right. So Locators rule. The derivative of 1 is 0. The derivative of negative 1 over x is negative 1 over x squared divided by the derivative of 1, 0 minus 1 over x is negative 1 over x squared minus, plus the derivative of ln is 1 over x. 1 over x. Well, I did the calculus, now I substitute. If I substitute 1, I get negative times negative, which is positive 1, divided by negative times negative is positive 1, plus 1. So I get 1 over 2. A half is the y value. Very well. We're going to talk about how to analyze graphs of rational functions. For example, without using a graphing calculator or graphing website, we start analyzing rational functions. Rational functions graphs. Very well. Okay. Example. In this example, we're going to graph a function without using a graphing website or graphing calculator. So you have y equals to 2x squared divided by x squared minus 1. X squared minus 1. In the very first step, when you have a function, you should be finding the domain of that function. Step 1, what is the domain? How do we find the domain of the rational function? The domain of a rational function is r minus the roots of the denominator. Domain is equal to r, all real line numbers minus the set of roots of the denominator. So it is r minus, what are the roots of the denominators? Plus minus 1. We accept every real number except for 1 and negative 1. Why is that? If you plug in 1 and negative 1, you're going to end up with y equals to a number divided by 0. You're going to end up with asymptotes. So in the next step, step B, the second step, find X-intercept and Y-intercept. X-intercept and Y-intercept. Well, to find X-intercept, we're looking for the values that make the numerator equal to 0. So find the values that make the numerator equal to 0. So by solving the numerator equal to 0, you only have one x value. X is equal to 0. When x is 0, your y is going to be 0. This is your x-intercept. At the origin, the graph hits x-axis. What about y-intercept? To find y-intercept, we set y equal to 0 and solve for x. Set y equal to 0 and find x values. Well, when y is equal to 0, your left-hand side is equal to 0, you have a fraction on the right-hand side. Your fraction is 0 if and only if the numerator is 0. So again, 2x squared is equal to 0. It means that your x is 0. When y is equal to 0, your x is equal to 0. So it means that your x-intercept and y-intercept, both of them happens at the origin. Zero and 0. Okay, after finding x-intercept and y-intercept, we are interested in checking to see if we have an even function or odd function. Step 3. Even or odd. Well, to check to see if you have even or odd function, we need to substitute x by minus x. Substitute x by minus x. So in this case, you get y equals to 2 times minus x squared divided by x squared minus 1. Now, instead of x, we have minus x squared minus 1. Well, if you square negative x, you get x squared back. So you have 2x squared divided by x squared minus 1. We get the function itself. What's the meaning of that? It means that f of negative x is equal to, so by negative x, it means that f of minus x is equal to f of x. It means that the function is even function. We have an even function. F of x is equal to f of minus x. Well, here it means that you have a symmetry with respect to y-axis. With respect to y-axis. So we already, so far we know that we have an even function. What else we need? We need to find the vertical and horizontal asymptotes. So in step 4, asymptotes. So to find the vertical asymptotes, we just need to find the zeros of the denominator. Vertical asymptotes set the denominator equal to 0. So x squared minus 1 is equal to 0. It means that x is 1 and x is negative 1. It means that you have two vertical lines, two vertical asymptotes that divide the graph in 3 pieces. Two vertical asymptotes. What about the horizontal asymptote? To find the horizontal asymptote, we need to find the limit of the function as x goes to infinity. Limit of 2x squared divided by x squared minus 1 as x goes to infinity. Remember that since the degree of the numerator and the denominator are the same, the horizontal asymptote is equal to the coefficient, leading coefficient of the numerator divided by the leading coefficient of the denominator. 2 divided by 1 is 2. So y equals to 2 is the horizontal asymptote. Well, in step 5, we're going to use the derivative to find the maximum, minimum, and inflection points. Step 5, find max, mean, and inflection points. Very well. Now let's take the derivative of this function. Remember that to take the derivative, we have to apply the quotient rule. Well, what do we have? We have 2x squared divided by x squared minus 1. The derivative of numerator is 4x times the denominator minus the derivative of the denominator, which is 2x, times the numerator, divided by the denominator squared, x squared minus 1 to the second power. So this guy is equal to, let us distribute 4x. We get 4x cubed minus 4x minus 4x cubed divided by, here we have x squared minus 1 to the second power. We can cancel out 4x cubed and 4x cubed. What's left, guys, is negative 4x divided by a quantity raised to the second power. Well, what does it tell us? It tells us the critical value is x equals to 0, and the rest of them are plus minus 1 that we actually eliminated from the domain. So x, if you set this equal to 0, then x is equal to 0 is the critical value. And if you plug that guy into the original function, you get 0 as the y value. So 0 and 0 is the critical point. So let us take a look at our table. X equal to 0, and then here we can analyze the function itself, the derivative of the function. You can say that, well, here, if I plug in, for example, a positive number like 2, what I get 2 times 4 and divided by 4 minus 1, I get a positive value. If I plug a negative number, then I get a positive value. So if I start analyzing the derivative itself, take a look at the derivative. If I plug in 1 into the derivative, I get a negative number. So if I plug in 1, let us write a half, because if I plug in 1, 1 doesn't work here. It makes the denominator 0. So if I plug in a half, I get a negative number. The derivative is negative. It means that the function is decreasing. Then if I plug in, let's write this, oh my God, on this side, a half, then I get negative, the function is decreasing. If I plug in negative a half into the function, then I get a positive number for your positive value for the derivative. It means that the function is start increasing. So at the critical value 0, on the left, the function starts increasing, then starts decreasing. This is the behavior so far. Very well, excellent. We analyzed the function so far, and these are the information that we have. So let us try to sketch the graph with the information that we have so far. Let me erase or just write them down here. I need all of this information. Then I need a little bit of space for the second derivative. So step 1, the domain is R minus plus minus 1. And step 2, we find the X-intercept, which is X equal to 0, Y-intercept, Y equal to 0. At each of these, you get the same value. So it is 0 and 0. In step 3, the function is even. We already know that. Step 3, f of x is equal to f of minus x. We have an even function. It means that we have symmetry with respect to the vertical axis. Then we found the vertical asymptotes in step 4. Vertical asymptotes happen as x equals to 1 and x equals to -1. These two are vertical lines. And then we found the horizontal asymptote, which is y equals to 2. Horizontal asymptote, y equals to 2. Then for maximum and minimum of the function, let me copy this down here. Step 5. The derivative max minimum. Max min inflection. Well, the derivative of the function is equal to here y prime is equal to -4x divided by x squared minus 1 to the second power. And we saw that at x equal to 0, which is our critical value, this is the behavior of the derivative going up and going down. Going up, then going down. Like if you plug in x equals to -1/2, x equals to 1/2, this is the behavior. The function goes up, then goes down. What about the inflection point? So to understand the inflection point, we need to take the second derivative of the function. Well, we can graph it somehow with the information that are given to us. Vertical asymptotes. So for vertical asymptotes, you have x equals to 1, x equals to -1, and x equals to 1. These two are your vertical asymptotes, dividing the graph into 3 pieces. And you already know that at x equal to 0, y equal to 0, you have the intercept. And at the same time, you know the graph goes up, goes down. So some part of the graph behaves like this. Goes up and goes down. Now we have to analyze the rest of the function. And your horizontal asymptote happens at y equals to 2. Let's use a different color for y equals to 2. This is your horizontal asymptote. Very well. So the second derivative of this function. The second derivative of this function, again, you have a quotient function. It means that you have to apply the quotient rule. The derivative of the numerator is -4 times x squared minus 1 to the second power minus the numerator times the derivative of the denominator. So this is 1 The derivative of the denominator is 2 times x squared minus 1 times 2x, the whole thing divided by x squared minus 1 to the 4th power. Before distributing these, try to get rid of the common factor. The common factor here is x squared minus 1 and x squared minus 1, but it has exponent 2. So if you simplify this guy, your second derivative becomes -4 times x squared minus 1 minus 4x times 2 times 2x. And since we took one of these factors, the exponent becomes 3. Exponent becomes 3, x squared minus 1 to the 3rd power. Well, now let us write this in expanded form. We get -4 times x squared, so -4x squared plus 4, and here you have plus, and here you get 16x squared divided by x squared minus 1 to the 3rd power. This is equal to 12x squared, 12x squared plus 4 divided by x squared minus 1 to the 3rd power. If you set this equal to 0, you get x squared equals to negative numbers. If set 12x squared plus 4 equal to 0, then x has no real solution. So what we can do, we can say that, hey, the sign of this fraction only depends on the, actually not even the denominator, because whatever you plug in here, it's going to be positive, and here you have positive. If it's positive, going to be positive. If it's negative, again, you're going to be positive. What you can say that, hey, the second derivative doesn't give me any information that I can use to analyze this function. Well, what's left? What's left? What we can do with this function here, this rational expression, rational function that we have? Well, let's see, can we analyze this further? On the numerator, everything is positive. What about the denominator? Let's think about the denominator. So take a look at your denominator. This guy is always positive. What about your denominator? If you think about x squared minus 1 to the 3rd, the behavior is like this. At -1, so I'm talking about x squared minus 1. And here, eventually, you can add 3. So 1 and -1. If I plug in any number between 1 and -1, like 0, the outcome is negative. If I plug in anything larger than 1, less than -1, it's going to give me positive. What's the meaning of that? It means that this fraction, the whole fraction depends only on the denominator. So what's the meaning of that? It means that the concavity is up, the concavity is up, and the concavity is down. Between -1 and 1, the concavity of the function is down. The function concave down, and before -1 and after 1, the function concave up. Concave up. Wow, okay. I'm getting somewhere. Another thing that you can do, you can set your 2 equals to the y value of the function and try to see if you can find an answer for it. It means that can you find an intersection between your horizontal asymptote or the function itself? So what you can do, you can set this equal to each other. 2 equals to 2x squared over x squared minus 1. So you get 2x squared minus 2 equals to 2x squared, but it doesn't give me any information, any solution. It means that the graph itself has no intersection with y equals to 2. Graph has no intersection with y equals to 2. It means that it is above your horizontal asymptote. So it means that since we already know that it concave up, it doesn't touch the vertical asymptote. And also here, it doesn't touch your vertical asymptote and neither the horizontal asymptote. So this is the graph.